-1, and that would be 18. Dalton gave us the definition of elements compounds, but he said one thing that was wrong. He said that all atoms of every element are the same, and that's not true. We talk about isotopes. Isotopes are elements that have the same number of protons but different number of neutrons. So an ion, the charges are not equal. An isotope, the mass numbers are not equal. Now this is isotope notation, or the notation for a single atom. All right, not for an element, but just for when we're talking about one particular atom. When we write it out like this of course is the atomic symbol, or the chemical symbol, I should write. Where A is what we call the mass number. The mass number is equal to protons plus neutrons. This is different from the mass on the periodic table, which is an average. The Z gives us the atomic number, which we've already discussed is equal to the number of protons. Now, there's one more thing we're going to put on here, and that is going to be right here. If we have an ion, the ion notation, the charge goes up here where the B is. So this is the charge, and as I said, the charge is equal to protons minus electrons. So add that into your notation. There we have it summed up for you. Mass numbers equals protons plus neutrons, and the charge is equal to protons plus electrons. So let's see if we can figure some out. P for phosphorus. Phosphorus has an atomic number 15. How many protons does it mean it has? That's right, 15, because the atomic number is equal to the number of protons. It tells us it has 32 for its mass number. Remember that mass number is equal to protons plus neutrons. If we have 15 protons and we know the mass number is 32, how many neutrons must we have? So you just solve for n. 32 minus 15 would be 17 neutrons. Electrons, remember, are going to be based on this charge, and there is no charge there. So there are no electrons. The electrons will be equal to protons, which is going to be 15. In our set, and I'm going to tell you right now, all of these are going to be equal to, all the electrons and protons are going to be the same, because this is a much simpler one than we're going to do in class. Next one, it tells us that we have 29 protons. That tells us that our atomic number is 29. If we look at the periodic table, copper is that element. It tells us we have 36 neutrons. To get the mass number for copper, we have to take 29 plus 36, which is 65. And then, again, we don't have a charge. We have no way of knowing if there's a charge. So for now, we're going to assume it's the same. For our third one, again, if we assume that there is no charge, 18 electrons and 18 protons would be what we're talking about. And 18 is argon. For a mass number, 18 plus 21, we would have 39, if I did my math right. All right, so that gives you a little bit of practice using the nuclide symbols, or the isotope notation. That gives you a little bit of practice with mass numbers. We didn't get any practice with, well, let's do an ion real fast. Get another page here. what if I tell you I have magnesium? How many protons does he have? He has 12. How many neutrons? 24 minus 12. Electrons are going to be charge equals protons minus electrons. So if you've got 12 protons, how many electrons must you have? Hello, Mrs. Clement. Would you like to say hello to the kids?
Hi.
Isn't it fun?
It is. See you later.
So yeah, 12 minus what would give you 2? 10. So there are 10 electrons. Another one, if we do nitrogen, nitrogen has a -3 charge. We'll do nitrogen 15. Nitrogen would have 7 protons. Neutrons would be 15 minus 7, or 8. For electrons, we're going to have a -3 is equal to protons, which is 7, minus electrons. 7 minus what is going to give us a -3. Solve for the electrons, you get -10. All right, there's a little practice for you. All right, let's do ions. An ion is an atom that has lost or gained 1 or more electrons. An ion's a charged particle. It has a charge. The octet rule states that atoms will lose, gain, or share 1 or more of their valence electrons to achieve a filled outer electron shell. Ions that are positively charged are called cations. Think of it as the cool cats. That's positive. And ions that are negatively charged are called anions. Think of it, anions sound like onions, or looks kind of like the word onions, and onions smell. That would be negative on your date. Cations are formed by losing electrons. They are usually formed by metals. Anions are gaining electrons and are usually nonmetals. Cations are smaller than their atoms. So if you lose an electron, you're actually going to get smaller. Anions, though, if you gain an electron, you bulk out, you get bigger. Lithium forms a cation with a +1 charge. Fluorine forms an anion with a -1 charge. Can we predict the charges? Yes, charges can be predicted by their element's place or position on the periodic table. There you have it.